Hey, Mr. Dunn here. I want to give you one more full example of using a chart, a data table, in order to make a prediction. So, with this example, we've got a table and we're showing the predicted annual, that means yearly, cost to raise a child from birth until adulthood. And so it gives us this chart of data starting at 1988, ends in 2000, but we want to make a prediction about the year 2011 given the data in this chart. And then we'll actually expand that into modern times. I have some newer data as well. We'll confirm that too. So first we have to find the line of best fit. We're going to take these 5 data points. We're going to go into Desmos and we're going to make a table out of them. So we make a table and you want to put the years in the left-hand column, and then whatever numbers are associated with those in the table, you're going to put in the right-hand column. It'll look like this when you're done filling stuff in. Now, of course, this doesn't display anything because we need to zoom out a lot because we have numbers in the 10,000s and in the years, 2,000 or so. So we're going to zoom out a really lot of times and look up here. That looks almost vertical to me. So what we're going to have to do, we're going to have to do a little bit of a trick here. We're going to display different stuff on the X and Y axes. All right, so I'm going to go from 0 to maybe 2100 or something in the X. That might work out okay. And then the Y's, I'll start it out at 10,000 because our first data point's a little above that. And then I'm going to keep this going until maybe 25,000. Now we got to see, does that make a difference? The answer is no, not really. It looks more diagonal, but we got to go even further. So we're going to, again, we're going to go into the X's. And with the X's, let's just start at like 1980. And since we want to predict to modern times, it's 2020 in this year, let's go to 2022. And look, it's a line. We just had to look at fewer of the X's. Or it looks like almost a line, right? It's a scatter plot. It's something that's close to a line. With this, we're going to type out Y1 squiggle, which, by the way, is located, if you're on a touch screen, it's located in the ABC below, about where the space bar is. Y1 squiggle MX1 plus B. If you type that exact line, we see the line of best fit get drawn. Our M is 510. And of course, it's giving us a very strange scientific notation here. So we have to interpret that scientific notation. And by the way, if you ever want to, just as a heads up, you can just type in the scientific notation number if that is a little bit confusing to you. And it'll literally tell you what number that represents in standard form. So the B value it's giving us here is, it's interestingly negative number. It's negative 1,003,600. So, okay, now let's go back into here, and we can write in the line of best fit. Remember, that's a y equals mx plus b line, where our m value was 510. And because the b value was negative, we're going to say negative 1,003,600. It's our line of best fit. So if we want to predict something with it, we're going to plug in the year 2011. Now remember that the year 2011 is representing an x value, since the x values were the top row of our chart. I'll plug in 2011. So we have 510 parentheses 2011 minus this 1 million number. I certainly don't want to do that in my head. So we'll go back over to Desmos. 510 parentheses, and the year was 2011. And subtract 1,003,600. And that's estimating for us 22,010. And that's the 2011 estimate. And so that would be the answer to your problem. But I was just thinking, like, it's 2020 right now. And we don't know if this trend is really going to continue. It was true here for 1988 through 2000, but it's hard to know if it holds true in the distant future. If we look 11 years in the future, it was $22,010. But it's very interesting to note that I did a quick Google search, annual cost of raising a child, and there's 2017 data here. This was the best yearly amount of data I could find. And in 2017, it cost $21,000. And we would expect this because of how that line was working in Desmos here. We would have expected for 2017, we would have expected actually that the cost would have been, we would have expected the cost 25,000 instead of this 21,000 number. So actually we're beating the estimate a little bit. That's an overestimate using our linear regression model. I mean, that's good. You don't want it to cost more money, of course. But yeah, interesting to see how that works out now. So there's a full example of a prediction. I hope you found it useful.